Good afternoon or good evening or good morning, everyone. We're on to session 5P of the Kick stream, so hopefully you're in the right room. We've got Chris Hodgins here from IBM, and Chris is going to give us a presentation on Resource Builder and resource overrides. Chris, are you happy with questions? They'll come up in the chat, and we'll call them out if we spot them. Is that okay?
Yeah, that's fine. Yep, that's absolutely
okay. Well, without further ado, take it away, Chris.
Excellent. Cheers. Okay, thank you. So let's go on. So I'm going to talk today a little bit, as Rob said, about the resource builder and resource overrides. I just wanted to quickly touch on another subject, another product which is just out now in March, which is IBM's EOS container platform as well. That also sits under the banner of configuration as code and fits nicely in a DevOps pipeline, for example, alongside the resource builder, resource overrides. But it allows you to containerize your applications and tools in a very portable way, so you can take those through from development into production, or you can share your tools with others in your team through registries. So I'm just going to quickly touch on that, and then we'll get onto the main two tools we're going to talk about. So one of the reasons why I wanted to talk about this is because in this end column here, for example, 70% of enterprises are looking at adopting things like DevOps self-service by 2027. So that ties right in with Resource Builder and Resource Overrides, which, as we'll see, has YAML-based configuration, which sits right in your source code management repository alongside your other artifacts like your COBOL source, for example. We also have 25% of enterprise applications potentially going to run in containers by 2027, and 90% of global organizations running containerized applications in production by 2027. So not only are we looking at DevOps here, but we're looking a little bit further ahead towards containerizing applications and containerizing those applications and tools to run on Z alongside things like Resource Builder and overrides. So you get a whole bunch of benefits if you've never seen or experienced containers before, around portability and just being able to very quickly package up everything together and have a complete confidence that it's going to port to another platform and run in exactly the same way. So it really does enhance how quickly you can move in your development systems. So just a quick example here, and then we'll get to the main topic, which is around sort of the life cycle of a development application. So here, IBM already provides a Java image, which is wrapped up that you can then run however you want. Christina, in this case, as EOS system programmer, can pull that Java image. She can make it look more like something you would expect in your enterprise, so any customizations you want. And then this application developer dev can pull the enterprise image from Christina and then is able to add on the applications and tools that they need to run, which can then be deployed straight into test production. So for example, if you wanted to, you could take the resource builder, for example, and containerize that, and then you put configuration that you wanted into that container and use that as part of your DevOps pipeline. So a really powerful tool that's been just out in March. We've released images for ZOS itself, plus IBM Java 8, and there's a ZOS Connect image as well at the moment. It's just been out this week. So moving quickly on to the CICS transaction server resource builder. So the goal of this was to look at resource management, and we wanted to sort of look around this theme of an application developer can define CICS application resources that conform to company standards in a source code management and be confident that they are acceptable for use in production. So very much configuration as code. We want to take the resource management lifecycle, wrap that up into a configuration file which can exist in source code management that is going to sit alongside your other source, but also gives a little bit more control and confidence that what you are defining is actually going to be acceptable, is going to pass the standards your system programmers have defined and for their needs, and also that the application developers can still define what they want. So we're going to look at two roles, and here is Alan, the COBOL developer, who is trying to get his resources defined and added. Normally, he would raise a change request to that, and the system programmer, Stan here, would review the change requests. He would batch those up as needed, and then would apply those to relevant CICS regions for the development teams. So this can take a little bit of time, and so obviously it's not in the sort of DevOps manner. You'd expect the developer to be able to go ahead and make the changes he needs without having to talk to too many people to get the job done. And Stan isn't here trying to block anything. He's just trying to make sure that the right resource changes are made that suit the right regions and the right infrastructure requirements that they have. So, solution for Alan. Alan would like to define the new CICS resources quickly. He doesn't want to raise a change request. He doesn't really want to interact with Stan, but he is aware that he has to meet the standards that are required of him. And so for Alan, we're looking at a solution where we can provide him with some configuration as code. So a YAML file in this case that could describe the CICS resources, and a DevOps tool that could build from those that YAML configuration and be able to generate resource definitions in a format that CICS can understand. So we can create resource definitions, and we can then use those with CICS to install them. And Stan would like a process to be able to handle all this the resource definition needs, but he has standards that he has to make sure are enforced. And so for Stan, we're looking at another piece of YAML called a resource model, and also an application constraints file, which will allow him to define the standards and rules that he wants to be enforced inside his environment. And he'll be then able to use the DevOps tool to enforce that those standards as they carry out builds. So Stan defines a resource model to enforce these standards and naming conventions. Specifically, he cares about things like naming conventions and which resource attributes are allowed to be set and which ones need to take on specific values. So Stan downloads the resource builder tool from IBM, which is a free tool that you can get access to. And he uses that tool to create a resource model. So he goes off and he builds a resource model. It looks a bit like the thing on the right here. It's got an application section which allows him to define some constraints about the naming conventions used with this application. And it allows him to define what the resources that are in this application look like. So in this case, he's got a program which has some public attributes for name and group, which take on the naming conventions above, and a transaction which has a name, group, and program, which also take on some of those same constraints. And you can be as specific or as vague as you want to be with these. So Stan also defines his constraints and he enforces his naming conventions that he wants. It doesn't take him long because we have, you see at the top here, a JSON schema, which we provide for this tool, which allows autocomplete context-sensitive help within the editor that you choose. So Stan generates a schema for his developers. So Stan has created his rules, and now he wants to create those rules to give to his development team so that they can apply those rules to their resources that they're going to build. So the resource builder tool has a generate command, which allows you to generate a JSON schema file, which the development team can use with their integrated development environments. So they are able to take that schema and get auto completion and context sensitive help and validation immediately against the resources they're creating. So that will automatically ensure that Alan's rules and expectations are going to be met by the development teams even before they get as far as trying to deliver the fixes that they are delivering the new definitional changes. So Stan wants to validate his model, so he goes off and uses the build tool. He runs it locally, and he takes some sample resource definitions which he's created, and he takes the resource model that he has built, and he uses the DRB build command to turn those that YAML document and the resource definitions also in YAML that he has created, and that converts those out into a CSD input stream. So Stan is obviously happy. He can see that the resources are what he was hoping to see. He's able to check that he can make changes that go against the rules that he is trying to enforce. And he will see at that point that those rules cause the build to fail, and we do not get a CSD input stream at that point. So from a DevOps point of view, you can create your rules, you can create your JSON file to validate them on the fly. But when you come to build it, we take the rules from the resource model, we take any resources that have been supplied by the development teams, and you can build those and generate the CSD-UP input stream that you require to then update your CSD. So Stan's able then to start his CICS region. He checks out the new CSD. He looks at the resources that have been defined, and he can see that they've all been defined correctly with the rules that he has set up. And so happy with that, Stan then goes off to talk to his DevOps team to try and integrate this into their DevOps pipeline so that then the development team can then build their source and also have the resource builder tool run to build the CSD resources that they require for that application. So they contact Denise, who's their DevOps engineer, and she agrees to add a new step to their pipeline to add in the resource builder tool. And you can see the pipeline running in the middle there. It extracts a source, so including like maybe your COBOL application source. It runs through all the automation to compile that application up. And then after that, it can run the resource builder tool to process the YAML and turn that into the CSD input stream, assuming that it does meet the requirements that Stan has enforced. And then after that, if you want to do other steps which go on and update the CSD and maybe even provision CICS, you can certainly go ahead and do that as well. So Alan wants to define resources now and is confident that I want to be confident that they conform to the standards and naming conventions that Stan has set up. So Alan goes off to develop his new resource definitions for his COBOL application. He makes a change to COBOL code, but he needs a new transaction, so wants to add that into his source. So he already has the starting point that Stan gave him. And so now what Alan's going to do is he's going to go in, he gets the JSON file that Stan has given him, he assigns that to the YAML file he's working on, and you can see at the top here that his IDE has already spotted that the JSON file is for his mortgage application, and he will get advice and context-sensitive help. So here we're seeing that the program name has hover help over it, and he's getting some information about what sort of values are suitable for this attribute. And it also says with a prefix of MTG. So that is the naming convention constraint that Stan defined earlier being applied. And if he makes changes to go that do not comply with those rules, he will get errors back to say that, what was wrong and why. And that all happens before he even thinks about delivering any changes. So Alan is quite pleased, doesn't have to email Stan, doesn't have to fill out a form, gets immediate feedback on what he wants. And when he's ready, he can go ahead and deliver this. And he knows that it will still continue to work because his IDE tells him that, there's no problems, it complies with the rules, so the build should work successfully. And even if the build doesn't work, you've still cut that pathway down a whole bunch. He doesn't have to go talk to Stan all the time, only on occasions he may have to do that. So Alan now is ready to try out his changes. So he goes off and he takes his source, his COBOL changes, he takes his YAML, all in his source code management repository. He creates a commit, he pushes that commit, and that triggers the automation job to run. So at this point, the automation runs as normal. It extracts a source, it does the compile, it runs the resource builder tool with the rules that Stan defined, but also with the YAML that Alan has now created. And if that all is successful, then the CSD-UP input stream will be created and put into the artifact repository for the next step of the build, which will pick that up and apply it to a CSD-UP job. And that will then cause your definitions to be defined into CICS. So Alan is happy. So rollout of the resource builder was going well, but Stan needs to now support additional applications. He doesn't really want to recreate everything every time. He went a lot of effort to create the original resource model. He doesn't really want to create another one for each application. So Stan is able, after reading the doc, realizes that the resource model has split into the resource model section itself, but also the application constraints that he created earlier can be split out to separate applications, into a separate YAML file. And these are both able to be auto-completed and still have context-sensitive help and give you all the usual updates you need to be able to get this done quickly. But with them in the separate files, it now allows Stan to start thinking about creating different application constraints for different applications, but maintaining the same resource model that they're using for these types of applications. So Stan goes off and creates an accounts application. So he's already got this mortgage one. It had the MTG prefix and this M prefix for their transactions. He now changes those prefixes to be different for the accounts team. So this accounts package uses ACC, the naming prefix. It uses A for the start of the transactions. And so with one quick move, Stan is able to redefine the constraints for a new application, but still sticking to the original resource model, resources. So in a very similar way, Stan is able to generate schemas for each of these. So he can take the application constraints, the resource model they had before, and generate a JSON schema file. And he can do that for the accounts application, or he could do that again for the mortgage application and create that one separately, while still using the same resource model. And Denise will go off and she'll update the DevOps pipeline, and that will give support for the resource builder tool to build against either application. So it will take the constraints for the specific application being built and the resource model that is shared between those applications. And again, you'll end up with a CSD input stream, which you can then use to update your CSD. And so just going on a little bit further is again, so this time round, Stan is going to do the same thing again, but this time we're working in an environment where the application is going to be deployed into a shared CSD. Now, the CICS resource builder handles isolation of these resources that are going to be installed at the CSD group level. So it assumes that it is able to create CSD groups, the resources into the CSD groups that are defined for the application each time. So normally I would expect that the CSD is in a set known state without those groups installed in it. And when it comes along, it will simply add those resources to that group, and the application will be deployed fresh into that CICS region each time. Now, if that isn't the case and you use a shared CSD, that's obviously not going to work. You're going to have to repeatedly redeploy the application into the CSD, and you need to be able to remove any CSD groups before those resources are added. So this time round, Stan adds a prepare option to his ZRB build command. And the prepare option tells the resource builder that you also want to generate a set of delete statements that are going to come out in the CSD UP format again. And this allows you to take an application. It allows you to, first of all, delete those resources, the resource group, CSD groups, sorry, from the CSD, and then define the groups again and resources into those groups as you after that's done. So that allows a shared CSD then to be both maintained well enough that the application can be deployed. And the prepare step here is simply is preparing the CSD for the deployment of the application into it. Okay, and again, Stan contacts Denise, and Denise updates the DevOps pipeline again to run these prepare commands as well. And the two CSD input streams, the prepare stream and the resources stream, go together into the artifact repository that the build generates output from. And a subsequent step simply pulls those both down, concatenates them together potentially, and then runs a DFH CSD UP job to apply those to the CSD. So that is a very, very quick overview of the CICS resource builder. It doesn't cover everything the resource builder does. The resource builder also supports an import option, which allows you to take an existing CSD and import those resources and generate on the fly the resource model, the application constraints files. It builds those for you with a little bit of an app. Basically holds your hand as you analyze your CSD and helps you spit out the right resource YAML for you without doing any further work. So the resource builder is available now to download. It is freely available. You can download the zip file and apply it. The documentation is there, and you can go off and get any compatibility reports that you want. But the resource builder generally runs on anything that has Java 8 installed into it. It's a Java tool based tool. So as long as you have Java 8, it should run in most environments. All the IDE extensions and things like that, I'll just quickly show that. So I've got a Visual Studio Code here. It's got the IDE extensions installed. So for example, if I look at my application constraints, you can see I can create, like, if I go back here, I can create a new constraint very quickly, and it will autocomplete everything that I want to do. And it will tell me when if I put silly values in, like a bad example actually, but if I put in, should do here, no, not that one. So, but it will tell me whenever I go astray without outside of the rules. So, for example, if I go to my resource model and we look at like the program constraints, I want to create a public attribute. Well, I can go in here and I can auto complete, and it will give me all of the program attributes that I want to use. So, say for example, I wanted a status field there, I could say that's required, or I could create a private field, and let's say we say concurrency, and it'll auto-complete and give me all the options. So I don't have to do a lot to move quite quickly here. All right, so that's the resource builder. Is there any questions on that before we keep moving? Is there any questions in the chat?
No question.
No questions. Okay. Right, well, let's move on. Oh, that's right. Okay. So yeah, so it's available from it supports 5.4 and above CICS. If you've got an IDE and you want to get these extensions in, we're using the Red Hat language, YAML language server here, plugged into VS Code, the extensions in there for the clients. And that gives you all that autocomplete context sensitive help. It allows you to assign JSON schemas to your YAML. So it's a very quick and easy way of getting instant validation on what you are setting up resource-wise before you get there. So I've got a quick pipeline example of the resource builder in action. So we're going to look at a pipeline that looks a bit like this. So Alan and Stan here are both Alan, obviously the application developer, Stan, the system programmer. And Alan's going to deploy the CICS banking sample application, which we have. And this thing is stored in source code management repository, along with all the source for the COBOL. I think there might be some Java source in there as well. But it now also contains the resource definitions YAML file. And a separate repository for Stan and his CICS resource model and application constraints is over here. Now, they don't have to be separate. It's just the way we've chosen to split this demo up. So what we're going to see is we're going to see Alan deliver a change. That delivery is going to kick off a Jenkins pipeline, which is going to extract the files from the two repositories. It's going to build the tool. It's going to run the resource builder to take the resource model, application constraints, and resource definitions YAML that's collected from source code management over here. And it's going to build a DFH CSDUP file from that, which can then go into further stages of the pipeline to update the CSD, to provision CICS, etc. So this red line here really illustrates how far we're going to get. So we're going to get to the point with the pipeline where it runs resource builder, and we'll look at the output that generates and just see how it works in action. So I'm going to switch over to my player. So can you see that okay? No.
Yep.
Yeah. Right. Oh, that's the wrong one. Okay. So what we're going to see is this is the CBSA application, and these are the resources that our application developer is working on. It's going to add a new online main menu transaction called Omen. And he does that. He adds a description to it if he wants to say what it looks like, what it is. And he won't be able to add any extra parameters that haven't already been approved by Stan. So that will be enough to create the transaction and apply the rules that Stan has already set up. So he creates the commit, he adds a commit title to it, and then he will commit that and push that out to the main repo. On receiving that update, the Jenkins pipeline will trigger off a build. So we'll see that just in a second. So there's the build queue down there. And having submitted that to GitHub, it'll now go off and kick off the pipeline. And the pipeline, as we can see, follows the same steps that we just showed in that diagram. So it's going to check out the source code. It's going to extract the application files for the source. It's going to extract the configuration for the resource builder. It's going to compile and build the application. And then it's going to build the DFA CSDUP utility commands. And then it'll be able to publish those out to, in this case, Artifactory. Now, once he's done that, we'll be able to pull that information back out of Artifactory and just see what the resource builder generated. So the build's just running away here, and we'll just skip slightly ahead and allow it to complete. So once that has completed, we can go look at the output of Jenkins, and you'll see that the resource builder is run, should be listed here. So there's the build command that it ran, and the output of that is simply resource definition commands written, and it tells you where they went. So now the developer, we've got a little script here that allows the developer to go off and retrieve the information from Artifactory so we can see what it built. So the output of that was this file called CBSA CSDUP. And you can see in there that the banking transaction is now created. You can see the description there that is a result of the description that Alan put into the source code management repository. But there's lots of other settings as well, and these are dictated to Alan by the tool, and he has no way of changing those because they're part of the constraints that Stan has set up. So Alan is happy he's been able to create his transaction as he wanted. He can see that CSD will get the right results, and Stan is happy here because all of the requirements that he had are also already applied. Right, so that's CICS Resource Builder. So now we'll move on to a different tool called, well, not a tool this time around, it's capability of CICS, introduced at 5.6. And this is a capability called the CICS Resource Overrides. And these allow you to override resources as you deploy them into different environments. So typically when we think about resource deployment, you know, we have different modes of operation. We have a development area where we want to be in debug mode or fixing problems. We've got very specific, we might even have our own JVMs, we might have our own, we want debug turned on, we want our own ZFS, we maybe have our own development Apple IDs, some TCP IP services that we use. We've got some development debug tools maybe, and maybe some other specialist tools that we have set up for development. And all this stuff comes together in development, and we do our tests and it looks good. And then we take that bundle and we throw it into development to integrated. It gets integrated and everyone's now able to see those changes. And then we put it into test. And as it goes into test, we take off some of our little handholds. We take off our debug options. We maybe fall back, we remove some of our debug tools, and we now start using the sort of standard Apple IDs we expect. Maybe we've still got some custom stuff though, like ZFS. Maybe we've got some test IP addresses and some specific JVM setups. So we still have some things, but it's definitely less than development. And then as we get into production again, we take some more of those off, and now we are production ready. So we have this point where we are constantly trying to change our application to suit each of these different environments. So CICS Resource Overrides attempts to come along and remove some of that churn, but also to encode those changes into a configuration file, so it's obvious and clear what is being applied in each environment, and it can be analyzed and looked at and go through the same versioning process that other source changes go through. So in this case, you can see that the bank app never changes its version throughout, but what we're going to do at each step of the way here is we're going to apply a different set of overrides for each environment. So this time we've got development overrides, which are going to impact the resources that are going to be installed. Resource overrides comes along that attempts to override the attributes of resources as they are installed into CICS. And that can impact any resource installation from auto install to BAS installs to Explorer installs. All installs more or less get included in this capability. So as we obviously go through different environments, we've got different sets of overrides, and we'd like to think that as we go towards production, the production overrides will contain the least information, but again, still required to make your applications conform to those environments. So how does it work? Well, resource overrides allows you to create a YAML format again, so UTF-8 encoded file with YAML structures in it, which allow you to define how you override resources. Again, there is JSON schemas available for your editor, so you can get auto-completion and validation here, which makes it very easy to create these files very quickly and get validation proof that they are right before you put them into CICS. And then as you install production CICS resources, the overrides are applied to those resources as they're installed. And the overrides allows you to select the resources based on any of their attributes, allows you to override the values by setting the values something specific, to find and replace values within the attribute strings, to prefix and suffix resource attribute values with different values, and you can also now inject built-in symbols as well. As well as that, all this information that is what's happening to these resources is going to be output into the CICS messages to allow you to see what exactly has been overridden with what values and analyze any errors that have come out from that process. This also satisfies a bunch of user requested enhancements along the way, especially the introduction of the built-in symbols. It's very handy for injecting things like Apple IDs and sysplex names into the attributes that as they are installed. So we can select resources based on any attributes. This is the sort of format of the YAML file that you're going to create. So the first thing we have is the type of resource we are going to create. In this case, a transaction, a file, a URI map, enqueue model, all names of resources that you should be familiar with. And after that, we have the selector. And the selector contains a list of criteria that are going to be put together to select the resources that you want to work on. So in this case, the transaction is being selected with a name of BK star. So anything BK would be selected. And it has to have a program called BK star web, and then a group called bank web as well. Now, this is the sort of default way of setting things. This is sort of a selector that uses what's called the is selector. And it just says that the name is BK star. Now you can call these things out a little bit more clearly by using is bank star, which is exactly the same thing as what we see here. But there's also other operators as well that allow you to say, I would like the name to be bank star, but it better not be bank cust. If it is, don't select it. So these two things apply together. And then here we've got the name has to be bank star, but not bank cust, and it must also be in the group bank data. Now we can also use these literal and literal not options, which allow us to do the same thing, but when we have literal there, any stars we see are taken as literal values for the attribute values and not as a filter. So in this case, we have a URI map that has a host name, which is literally not star. So these all come, so this is our selection process. And then after that, we now want to override the resource attributes from the resources that we've selected. So again, this is at install time. So as things are going to be installed, CICS is going to look through the list of things you've selected. And then once it's found one, it will then apply any overrides you've set. So here we've got an overrides option, which says that it wants CEDF to be yes. So if this was like your development overrides, for example, any BK star web program it found that was being installed would have an override applied to it, CEDF yes, regardless of what was already set in the option. And then down here, we've got a URI map that is being selected. And once it's selected, it will override the path. And this is using the find and replace overrides. So here we will find anything in the path that has the word prod in it, and we'll replace the prod mention with the value dev. So it's very simple, a very way of overriding key values inside your path or any other attribute that you want to do find replace on. And down here, we're using the prefix and suffix options to prefix a file DS name attribute with prefixing it with dev dot and suffixing it with dot dummy. So whatever value you already have in there will then take on these extra values as well. Okay. And as we said before, we also support injecting built-in symbols. So we support quite an array of sort of symbols, and these are provided by these curly brackets. So you say curly bracket, and the name of the symbol that you want to use. So in this case, we're replacing the DS name with prefix CICS region user ID, and we're finding and replacing .prod with the name of the CICS LPAR. So that'd be quite useful if you've got like a development environment again, and you want to change out to use your user ID datasets, and you want to replace your .prod dataset name with your LPAR and just make it more customized to your environment. And again, we support all these different symbols being injected in. And the good thing here is these are runtime injection. So, you're picking up the real thing of the region that's running. So if you run it on a different region, you'll get a different value depending on what you've asked for. And we also support overrides that contain ranges. So we've got this 0:1 option here, and that says we want to prefix the CICS Apple ID, but only take character 0, which is the very first character, through to character 1. And we also support a length option with double colon. So if you said 0::2, you would get the first 2 characters again of the length of 2, going from character 1 and character 2. So that's the built-in symbol selection. Again, very powerful when you're doing this. And all you have to really do is set up the overrides file and give it to CICS. And from there, it will automatically apply them. So this is what the complete overrides file looks like. It's not much different from what we've already seen. The only real difference here is it's got a schema version now, which tells you what the format of the resource overrides file looks like. So the IDE knows how to validate it. And so you can see what version you're using. And it's got a resource overrides of high-level parent object, which contains the overrides we just looked at in one after the other. And they'll be processed one after the other as well. So very straightforward, very easy to use. Again, we've talked a bit about the IDE setup. In fact, if you use your IDE, I don't have got any here, but you can create, if you create a file, I think it's, if I use like test.cics overrides, I think it's that one, then it should automatically work out that if it's got CICS overrides at the end of it, the IDE normally will work out that it's a CICS overrides file and will populate everything for you. So here you can see resource overrides, you can create like a bundle, and you can create a selector for it. And then you can pick what field in the bundle you want to work on. So you'd say there, status, I want it to be enabled. And if so, then I can create an override. And I want to override the bundle dir. And then you can go from there. Oops, that didn't work. So from here, you can put in whatever bundle dir value that you want and get the value set in the override. So very quick to work with, very easy to set up once you've got things ready to roll. So again, here you see like some examples of failing setup. You can see the IDE here telling you exactly what it expects to see. So on successful overrides, you get a nice message. It will tell you it's reading the overrides file. It will tell you the overrides are being applied, and you can see that what attributes are being set up here. And we carry on. You'll see that if you look in CMT, you can also see that the change agents are being altered as well. So if you see a change agent of override, you know that file has been installed but then overridden with some new values. If there's a failure, the overrides process always fails to start CICS. CICS will terminate as soon as it detects a failure to parse, a failure to override. These are all distinct failures. We don't want to bring up an application or a region that has resources in it which are not valid. So here we're looking at parsing errors. And again, it tells you exactly what line the problem has been detected on. And if we have an override failure, it's very similar, but you see in message user that there are, the failure is outlined quite clearly. It tells you what rule didn't get applied and a bit of information about why. In terms of actually using CICS resource overrides, we have from 5.6, we introduced resource overrides as a feature toggle. So that was the first time we had feature toggles in CICS. And you would use a feature toggle and you would specify the name of the file, the overrides file that you wanted to use. and then that would be taken from the USS config directory and into the resource overrides directory location. If you then activated that in 6.1, you would use a set parameter called res overrides, and it's exactly the same as the feature toggle. You just provide the file name, and from there you get your resource overrides applied. So if you're at 5.6, you do need a safe bar, but it's been around for a while, so you should probably already have it. Otherwise, the doc outlines how to use this. It docs into a lot of detail about the file format, how it's applied, and how the file's parsed, how to set it up with set and set values. And it goes into a lot of other information about things about like how cataloging works and all the different things that are supported or not supported with resource overrides. So just generally, just come back and sort of summarize on all of this. Together, these things provide a different approach to CICS configuration than maybe you're used to seeing. But they're both very much focused on this configuration as code approach, where the resource definitions, your configuration goes into YAML, it sits inside your source code management repositories. Everything is under version control and is able to be, you can always go from what happened back to the source code management changes that led to it. There's none of this, changing things on the fly inside some file on your LPAR to make something work better. That's not how it works. You have to go back to source code management, make the change there, do it under version control, pass that back through and redeploy and make sure that all works properly. So here we've got our bank app in source code management. We're going to build it using the resource builder. That can go across and build the CSD dataset. We can provision our applications into development, and then resource overrides comes along here, and we can apply a dev override to our region using the set parameter for resource overrides and make any changes we want to our app that we've now built using resource builder and deploy the overrides into the application to make it work for our development region. But the key is that our bank application can remain built for production, but we're just pulling back some of those settings a little bit to allow it to run in the development region so our developers can get on and make the changes they need. And these dev overrides could be part of the development, the application development source code management. It could be part of your system programmers repo. It depends on your levels of trust and how you want to operate. Is there any questions on that? We've got a bit of time left. Any questions in the chat? I don't see anything.
No, there's nothing in the chat, Chris.
Okay. Does anyone want to ask any questions about this process? Well, I know at least a few hecklers.
No, I think for me it's really interesting, and we've really got to have a go at it to ask some questions because I'm sure we're gonna get it wrong. But we've got some other things going on with definitions at the moment. This might help tweak it at the end. I'm not sure, but very interesting.
Yeah, thanks. I think that obviously the goal is to follow the sort of DevOps approach as much as possible to persist these things into source code management, so everything is under that same version control, and you know what is going through. And I know practically that always doesn't work out. Sometimes there's hot fixes required, sometimes there are emergency situations, but ideally everything ends up in source code management, so you've always got that auditability. You can always go back and see where the changes led to what problems, and you can react to that in the future.
Yeah.
I've got a bit of time left. The only other thing I can show you is I had a go at putting resource builder in a container if anyone wants to see that.
Sure.
See the process, yeah. I don't think I was actually of time, but I seem to have gone much faster than I intended to go. So let me just share that. Again. Just log in before we do that. Because I don't expose anything that I don't want to expose.
Yeah, Rob, it's probably worth letting everybody unmute themselves if they wish at this point.
Oh, absolutely, yeah, please.
In case anybody's desperately wanting to chip in.
Okay, can you see the shell?
Yep.
Okay, so this is our environment that's running container platform as well. I could do Podman images. Podman is a standard tool that we provide that is standard throughout the industry. You can access, and right now we've got ZOS latest image, we've got IBM Java 8, we've got ZOS Connect installed, and these are already pre-canned images that we can set up and use. So I could, like, for example, we could run a few options on it, but effectively you can want to run Java 8, that you can say like Java-version, and that will run inside the container. So it will stand up an entire ZOS container with everything in it running Java, and then you can run your commands inside that container and see that.
Okay, sorry to interrupt, Chris. There's a
Please.
question from Ian,
Absolutely.
and he's just asking if resource overrides can apply to BAS resources as well.
Yeah, absolutely. Yeah, that it applies to BAS as well, if you wanted to. Yeah, okay, so this is the resource builder. So I've actually just
Sorry, Chris, I was talking on mute. Sorry to interrupt.
Yeah,
So the override is actually applied when it's when the create SPI create happens in the CICS region.
Yeah, that's right. During that installation, as soon as the CICS resources attempt to be created, CICS goes off, looks through its overrides list, and analyzes whether it needs to select it, and then makes the override.
And it doesn't matter where that SPI create comes from. You know, like you could have a program after control been given that tries to create a resource, and the overrides would be applied. Okay.
Yeah,
cool,
absolutely. Yeah, exactly. Right. It applies whenever, as long as the region's set up for overrides, it will apply at all times.
Thank you.
Okay. So this is an example of, I said, I've just literally just downloaded this off the website, and it's a zip file that comes down. I've unzipped it, and there's nothing. It's just the normal CICS resource builder. It's got some libraries in it and a bin file with the ZRB shell in it, and everything that we normally provide. So nothing clever about that at all. And then I've created a container file, which is going to containerize this application. And all it's got in it is, I've said, from Java 8. So I want to take the Java 8 image. I want to use that as my base. That's where I'm starting. So I'll already have Java installed. I will take, I create a new path to my resource builder, which I'm going to slap into /CICS resource builder. Now, normally you wouldn't do that because, you know, that's not very nice. You know, there's locations for these things, but in a container, it doesn't really matter because it's your container and you can put what you like in it. You can delete the bin directory if you want for root. It doesn't really matter. So we're going to copy the CICS resource builder into /CICS resource builder. We've set our path up. I added this because we need to move env to user bin because the shell script for resource builder expects it. But this is enough to totally containerize the ZRB, resource builder. So all I do to build this is podman build. I specify what container file I want. Let's call it, I don't know, GSC ZRB, right? And so that'll be the name of the image I'm going to build. It will automatically pick up a latest tag to say it's the latest one. And it runs through this very quickly. And once it's finished running this, I will have an image that contains ZOS, that contains IBM Java 8, that contains the CICS resource builder. And so now I can see in Podman images that I've got a new GSE ZRB thing. And I can just run that. I can say like, GSE ZRB. I can say -- help. So let's just run help. Get the build for that. And so it will start up the container and then runs Java, and then we automatically get resource builder running inside of that. And, you know, we can say, if I wanted to change that, say like, you know, let's get the help for the build, just to prove I'm not making this up. Now, this is fun, right? It's not really any different from just running it, but it is different in certain ways. So like, for example, where we see all Podman images here. Now, if I've built this resource builder, maybe I've configured it specifically for my enterprise, I might then go, well, okay, let's give it to everyone else. So I could then do like a Podman push, and I could send my image to our artifactory. So maybe, I don't know, let's see. So our artifact repository, oops, let's call it artifactory, who knows, /GSC ZRB. And then that would then get pushed out, and then other people would then be able to run my image. They would also be able to do Podman run and it would Podman will automatically grab the image from Artifactory, bring it down, and then run it the same way I ran it. And I know it will work because all the images, all the libraries, all the dependencies have already been satisfied within this blob of an image, which makes it very, very easy for sending around to like your development environments, or sharing with a lot of people, or giving tools to developers, or running enterprise applications. You can see here I've got things like the ZOS Connect server as well, so we could, you can build like ZOS Connect API images on top of this server the same way you would do on Linux, and then you can deploy those as well throughout. So as part of a DevOps pipeline, it's an excellent approach, but also in terms of accelerating development and other practices through proper pipelines, can be very handy to be able to ship standard built images, which can then, if you take like things like your container file, you can persist those into source code management as well. And so they can all be part of your configurations code type of approach. So with that, I think that's really all I had to share at the moment. If there's any questions, I'm absolutely more than happy to take them. And if I've confused you all, then please do ask questions about that as well.
No, you haven't confused me. It's interesting to see containers been part of some of the discussions a few years ago, and how they've morphed and changed differently from what was originally envisaged. But
yeah,
it does look pretty straightforward for people to know what they're doing.
Yeah, I mean, it's one of those things that once you get your head around, it's actually so simple. It is really simple. It's like, I know a lot of things we do are like, they say they're simple and then they end up being like really complicated. But this is one of these things where it does follow the standard approach. It's really easy to define, and once you've got it up and running, it's really change and work with, and pass around. And the ability to just build an image and then pass it around to everyone. I can, like, for example, quite often we'll do demos. I can give the demo ready application to someone else, and I know it will work because it worked on my system. And you start up that container, it's got everything in it that you prepped for. It's going to work.
Yeah, brilliant.
Yeah.
Okay, Chris. Well, thank you very much for demonstrating 3 products. So
Yes.
3 in 1, very good value. And if anyone's got any feedback, there's a link which we'll post in the chat, I think, and it's on the last page of the foils. I would appreciate that. We've got 2 more sessions to go on the last day, and it's a sort of double header from our good friend Ezra Gross at the next session in half an hour at 3 o'clock. So Ezra's going to be talking about Liberty profiles on the mainframe. Thank you very much, Chris, and thank you everyone, and speak soon.